Hello class, in this lesson we're going to learn about linear motion in a rectangular region by looking at robots. So in our big example for today, we have students in our robotics class and they're programming the robot to go around an empty rectangular warehouse. It's 2,000 feet long and 1,000 feet wide, and we can put it on the coordinate plane. So we have the origin, there's the point 2,000, 1,000. So we know, according to the program, that after 1 second, the robot's at the point 30, 45. And after 3 seconds, it is at the point 50, 75. It's moving in a straight line at a constant speed. And we want to figure out the answers to these three problems. So using what we just learned, see if you can answer these three problems, and then I'll show you my solutions. So if you solve these correctly, you should have gotten this for the point of impact. You should have gotten this speed and 64 and 2/3 seconds. Now, maybe you didn't get all those. If you got some of them, great. But in this lesson, we're going to learn how do we find each of them. There's actually a lot of work that goes on behind the scenes to find these three answers. So that's our goal for today. So the first thing we want to do is we want to model our problem. So we want to plot those points in the coordinate plane. So going back here, we have the points 30, 45, and 50, 75. So make a rough sketch of that and draw a segment that connects them. So here's my drawing. It doesn't have to necessarily be to scale, but you should definitely notice that your segment should be rising to the right. What is the change in the x-coordinates here? How much did the x-coordinate change? Well, we just subtract the 50 and the 30, and we get 20 feet. What about the y-coordinate? It's that vertical change. That'd be 75 minus 45, which is 30. And finally, what's the ratio of the change in y to the change in x? Well, that's the same as slope, right? So divide 30 and 20, and we get 3/2, or 1.5. So using that information, what's the equation of this line of motion? So to do that, I'm going to use slope-intercept form. So we're going to need the slope, which we already have, and one of the points. So I'm going to use the point with the smaller coordinates. When we do that, you should get y equals 3/2 times x. So that means that our y-intercept must be 0, but we have to verify that. So here's slope-intercept form. We're going to plug in the point 30, 45, along with our slope of 3/2. And when we solve this, we end up with b equal to 0. So that's how we get that equation. So 3/2 times x. And what theorem can we use to figure out the distance between the 2 points? I'll give you a hint. We drew a right triangle there. This one's clearly not drawn to scale, but that's okay. We can see that we should be able to apply Pythagorean Theorem. So how far did the robot go in 2 seconds? Well, we just plug in c squared is a squared plus b squared. And we end up with c squared is 1,300. And to solve this, we take the square root, and we get about 36.06 feet. So keeping all that in mind, we're going to continue this problem, and I want you to predict where you think on the diagram that the robot is going to hit the wall. So which wall do you think will it hit and where? Well, if you continue the line that goes through them, you should see that it's going to hit the top wall first. And if we extend that line, it's going to hit there. And we can also verify that algebraically in a moment. So how can we figure out the location of impact? So GeoGebra tells us that we get these coordinates, but how can we find them exactly using algebra? Well, we know that this horizontal segment is contained in the line y equals 1,000. Right? Every point on this line is 1,000 feet from the x-axis. So if we plug in 1,000 for y, we should be able to figure out what the x-coordinate is. So we plug that into our equation that we found before, and we can multiply the reciprocal here, multiply both sides by 2/3, and we get that x-coordinate that we were looking for. Now, if you weren't sure which wall it hit first, you could also verify that the other answer doesn't make sense. If you thought it hit the right wall first, then you know that all of the points on this vertical segment are contained in the line x equals 2,000. Right? They're all 2,000 away from the y-axis. So if we plug in 2,000 for x, what happens? Well, we end up getting an answer that doesn't make any sense in our context because we get a y equals 3,000, but that's more than the width of the rectangular region, which is 1,000. So that couldn't have happened. It has to hit the top wall first. So another way to figure out the distance between 2 points is to use the distance formula. So you subtract the x's and square it, subtract the y's and square that amount. You add those two together and take the square root. Now, if that process seems familiar, that's because the distance formula is exactly the same as Pythagorean theorem, just written slightly differently. So I prefer to use Pythagorean theorem. It's a neater formula to look at, not as many variables, but either of them's fine. You'll get the same answer either way. So we already figured out that the robot traveled about 36.06 feet in 2 seconds. We did that with Pythagorean theorem. Now we're going to see that we can do that with distance formula as well. So if you use the distance formula, you would get 50 minus 30, subtract the x's. You square that, and you add that to the difference of 75 and 45 squared. And you see that's the same thing we have in this first line, essentially. 50 minus 30 is 20, 75 minus 45 is 30, and it's really just the same operations, just written differently. So you get the same answer. So how can we figure out the speed? We'll calculate speed. We know that that's distance divided by time. What would the units of speed be here? Well, we know we're calculating the distance in feet and the time in seconds. So speed would be feet per second. And what would the speed of our robot be here? Well, we already calculated the distance, 36.06 feet about. We're going to use the exact answer and then round at the very end so we don't get a rounding error. And we know that it traveled for how many seconds? For 2 seconds, right? 3 minus 1 is 2. So we take our distance and divide that by 2. And we get about 18.03 feet per second. So how far will the robot have traveled after 23 seconds? So once again, we don't want to use a rounded answer. We're going to use our exact ones and round at the very end. So we know that distance is speed times time. And we already know our speed from the previous part, and they told us 23 seconds. So we multiply these two numbers, and we get about 414.64 feet. So where did the robot start its motion? Now, what time was that? Well, keep in mind, we know the y-intercept is 0, but that's not necessarily where it started its motion. Or we have to keep in track of the time here. That's important. So we know that if it had gone far back enough, yeah, it would be at the origin, but maybe our initial time wasn't there. Maybe it was somewhere between the origin and 30.45. So at what time did it start? Well, if we look at the graph, we can see that the x-coordinate is changing 10 feet each second. So horizontally, 10, right? Because it's 20 feet in 2 seconds. And vertically changing 15 feet a second because it's 30 feet and 2 seconds. So if we go backwards here, if we went 10 feet to the left and 15 feet down, we end up with the point 2030 at time 0. So that would be our initial point. And so using our initial point, how can we figure out the distance from the starting location to where it hits the wall? Well, we know the starting location is 2030, and we know it ends up at this point. We calculated that before. So if we use Pythagorean theorem or distance formula, you get the same answer either way. We get our horizontal distance is this, our vertical distance is this one. And so we plug into Pythagorean theorem for the distance formula. And we end up with about 1,165.79 feet. And keeping this in mind, now we can finally figure out when the robot will hit the wall. Now, this isn't the only way to do this calculation, but it's the way that I wanted to go about it. You could have also used the other points, but just to add on the seconds that are left over. So we know that we have time is this distance divided by speed, and here we have the total distance divided by the speed. I'm not going to round them here. And when you divide them, you end up with an exact answer of 64.6 repeating seconds. So now when we go back here, we've learned in this lesson how to answer each part of the problem. So there's a lot going on behind the scenes here. You had to know about distance, right? Speed is distance divided by time. And you had to know about equations of lines to figure out all these answers. So in this lesson, we learned how to analyze linear motion in a rectangular region. Thank you for watching this video.